Welcome back to Electronics, Simple Circuits and Measurements Fundamentals. In the previous module, we introduced this workshop and what we needed to get started. Now, in this Measurements Principles section, let's explore how to measure electrical phenomena. Behold, the multimeter, an invaluable tool that allows us to measure electrical phenomena. By touching the probes of the multimeter to, well, anything, we can measure several different quantities based on the mode selected on the multimeter dial. Let's hit the ground running by connecting the probes to the multimeter in a sensible order. Typically, multimeters are color-coded, but if you're faced with a multimeter without color-coded ports, or one with more than two ports, it's important for us to know why we are plugging our probes into a given port. Let's start with the red probe. We'll connect the red probe to the socket that has labels such as V and Greek letter omega. These are used for everyday generic measurements. Next, we'll connect the black probe to the socket labeled COM. COM is short for common and can be thought of as the baseline for all of our measurements. In most cases, this point is considered zero or ground, but we'll touch on that later. A multimeter is an indispensable tool for making electronic measurements and diagnosing, or troubleshooting, problems in circuits. Its middle dial offers a slew of different measurements: voltage, resistance, current, and more. But for now, I want to focus on the function associated with this icon. Look hard, sometimes this icon is a secondary function of the resistance icon. If you need help entering this mode, consider Googling the user manual for your multimeter brand. Let's take a moment to pause the video and play with the multimeter while in this mode. What does this mode do? What did you find? Did you notice that in this mode, when you touch the probes together, the multimeter beeps? This is because this mode is called continuity mode, and when probes are connected via something highly conductive, the meter will beep. Continuity testing allows the circuit builder to test as you build when adding connections to determine if the circuit is wired correctly. You may hear an electrical engineer say, "Beep it out." This means use continuity mode to ensure that things that should be connected are connected, and that things that shouldn't be connected are not connected. This test as you build method will help you find the most common mistakes made while building a circuit, and will help you gain a confidence that the circuit will work properly when completed. So, it may be obvious that our multimeter probes should beep when they are connected to one another, since there is clearly nothing non-conductive between them. But what else is conductive? It so happens that one of the most conductive common materials is copper, which is what the wires in the probes are made of. You'll notice, though, that touching the plastic of the probe to one another does not produce a beep. This is because plastic is a very good insulator. This is why most wires have plastic coating. Wrapping conductive materials in non-conductive coatings ensures that you won't accidentally connect elements of your circuit together, called a short circuit. In a bit, we'll look at things that aren't quite conductors, but also aren't completely insulators. While we're still in continuity mode, let's explore one of the components that we'll use in our hands-on activities today. The breadboard is a piece of plastic with a grid of wires running through it. The sockets are arranged to make it easy for us to non-permanently create, design, and debug circuits. Let's use continuity mode to probe this mystery grid. Figure out which sockets are connected and which sockets are not connected. Just remember that the jumper wire is simply metal, so touching one of its ends to the tip of the probe will create a short, effectively extending our probe to the other end of the wire. Pause the video and take some time to explore. What did you find? You may have noticed that there are four sections of the breadboard. Two large areas of rows where sockets are connected horizontally. There's usually a channel down the center, breaking the rows into a left and right set of rows. Then on the outside edges of your breadboard are vertical rails. These sockets are connected to their vertical neighbors and run all the way down the edges of the breadboard. You'll notice that these are sometimes labeled with a positive and negative symbol, and may be colored. This is because the rails are often used as power lines, while the rows are meant for distributing and routing power through the circuit components. It is important to recognize that the breadboard is nothing particularly special. It's a bunch of metal wires assembled in a grid. The breadboard does not produce electricity, nor does it change it. It's simply here for your convenience. Now that we've become comfortable with our handy-dandy multimeter, let's move on to the principles of electronics in our next workshop module. See you then!